Okay, last time we have discussed about 1,3-diethene. In 1,3-diethene, what we have talked about, suppose if you are having aldehyde or ketone, okay, in that nature of the carbon we have discussed. Here the carbon which is attached with the oxygen, this carbon, due to the inductive effect and mesomeric effect of oxygen, oxygen is pulling electron from the carbon, and that's why these carbon become electropositive and oxygen become negative. But by using this reagent, means using the 1,3-propane dithiol, we will get 1,3-diethene. This 1,3-diethene, in this, if you treat this compound further by butyl lithium, when we are treating this compound with butyl lithium, replacement of this hydrogen will take place by Li, and as a result we will get 2-lithium-1,3-diethene. This compound we will get. Now in 2-lithium-1,3-diethene, as we know, lithium is highly electropositive. So lithium having tendency to donate electron, and as a result this carbon, this center carbon, become negative. So what we have done, we have started the reaction with the carbon. That carbon is electropositive, but after doing several changes or by treatment with the chemical, we are having the carbon, that carbon is having negative charge. Means we have converted, that is called from carbonyl C double bond O, C plus to C minus. So as a result, what we can say, we had electrophile, but now we are having nucleophile. The carbon is same, but the characteristic of that carbon is changed. So this is called reversal polarity or polarity reversal. Or in another way, we can call it a unprolonged characteristic. So this we have done with the support of 1,3-propane dithiol. After treatment with this compound, we are having the 1,3-diethene. That 1,3-diethene, by treatment with butyl lithium, we can convert it into 2-lithium-1,3-diethene, and finally we are having carbanion. Okay. Now this carbanion further react with various chemicals like RX. Here R may be alkyl, phenyl, then some substituted phenyl, something type of compounds, and X means halide. Normally halogen having tendency to pull electron, so what we will get? We will get R plus, and that R plus will bind with this, and what we will get? Substitution on carbon. How it works? Here the example. Suppose if we are having substituted benzaldehyde or substituted aldehyde, R equal to, suppose, Ca3, that is acetaldehyde, R equal to C6H5, that is benzaldehyde. So if you are having such type of compound, then by treatment with 1,3-propane dithiol, we will get 1,3-diethene compound. Then by treatment with butyl lithium, we will get 2-lithium-1,3-diethene. Means we are having now this compound where lithium is attached. As we have talked about the characteristic of lithium, lithium is always tried to be electropositive. When lithium is electropositive, it means this carbon become electronegative. Means carbon having now negative charge. Now when we are treating with RX, R means alkyl or phenyl or aryl alkyl type of group. In that case, what happen? R become plus and X become minus. X means halogen. Halogen having tendency to pull electron from the carbon. So it become X minus. So this R plus will react with the carbanion or nucleophile, and as a result we can see the substitution of R group. As I said, R may be alkyl or aryl alkyl type of groups. Then after, by simple treatment with HgCl2 plus water, we will get again C double bond O. So what we have done, we had a aldehyde and now we are having ketone. If we start R equal to Ca3, then we can call it the acetaldehyde. Ca3 C double bond O H acetaldehyde. Here Rx equal to suppose Ca3X, then it is called methyl chloride. So finally what we will get, Ca3 over here and Ca3 over here. So from acetaldehyde we have prepared acetone. So it is a direct conversion of aldehyde to ketone. So these type of conversion we can carry it out with the support of this reagent, that is called 1,3-dithiene. Several other examples are also there. Instead of normal Rx, if you are having R dash CH2X, means R dash equal to, suppose if you are having phenyl group C6H5CH2X, aryl alkyl halide. Now in aryl alkyl halide, we can replace this Li by this C6H5CH2, and we have introduced here this group, and as a result we can see the other substituted compound also we can prepare. Now if we start with the simple formaldehyde HCHO or HC double bond OH, then by treatment with 1,3-propane dithiol we will get 1,3-dithiene, and this 1,3-dithiene by treatment with butyl lithium we will get 2-lithium-1,3-dithiene compound, and then after by treatment with RCH2X we will get this intermediate. Now if we hydrolyze by HgCl2 and water we will get aldehyde. So from formaldehyde we are having now substituted aldehyde. But if we carrying out further reaction with the previously prepared, means this compound, by treatment with butyl lithium we will get Li over here instead of H, and then after by treatment with R-CH2Br we will get RCH2 C double bond OCH2R. So from formaldehyde we can prepare substituted aldehyde as well as we can prepare a ketone. So based on requirement, based on the reaction condition, we will get the different types of product by using this reagent. Here we are having two aldehyde groups, CHO and CHO, and this group are on the aromatic ring, and both aromatic rings are attached with one carbon, that is called CH2, methylene group. Now when we are treating this compound with 2 mole of 1,3-propane dithiol, we will get dithiene and dithiene. At two place we are having dithiene ring. This further by treatment with butyl lithium, and then after BrCH2Cl CH2 tri-Cl, what happened? Here one hydrogen is present. Here also one hydrogen is present. When we are treating with butyl lithium, these hydrogens are replaced when we are using 2 moles. So when these hydrogens are replaced, what we will get? Li over here, and then after by treatment with dihalo compound, first one Br is replaced, and then second halogen, that is Cl, is replaced, or Br first replaced, then Cl, and as a result we will get this compound. And after that, by treatment with HgCl2, water and CH3CN, we will get cyclic compound, that is called cyclic ketone. Here you can see ring is closed, so cyclic ketone we are having. So these type of derivatives we can prepare. Now instead of alkyl halide. If we are treating with epoxy compound, epoxy here only CH2O CHR. This is the compound. When we are treating with epoxy compound, then what happens? Here oxygen having higher electronegativity, that's why oxygen will pull electron. When oxygen will pull electron from this carbon become positive and this oxygen become negative. As a result, this carbon will attack on this position. So we will get CH2 CHR-OLi. And after that, by treatment with HgCl2 water and acidic condition, we will get RC11O CH2 CHOH R dash. Means in this compound we are having now two functional group. One is alcoholic OH group, second is ketone. So ketone and alcoholic group both are present in one compound. Suppose if we start with the ketone, that is called benzophenone C6H5C11O C6H5. In this compound, what happens when we are adding two lithium compounds, two lithium 1,3-dithiene compound? Here removal of oxygen or transfer of electron from carbon to oxygen will take place. As a result, these carbon become electropositive. Here the positive charge we will get, and as a result this C minus will attach over here and we will get this type of intermediate. And then after by treatment with HgCl2 water and C3CN as a solvent, acetonitrile as a solvent, we will get C11O COH C6H5 C6H5. So this is another kind of derivatives we can prepare by using this reagent. Now instead of alkyl halide, epoxy and ketone, if we are having nitrile, in the nitrile also, as we know, the electronegativity difference between carbon and nitrogen become negative and carbon become positive, and that's why these carbon ions C minus will attack on this carbon, and as a result we will get C11N Li and R dash. Then after by treatment with water at high temperature, we can convert it into RC11O, and after that by hydrolysis with HgCl2 water and methanol, we will get diketone. So this type diketone also we can prepare. Now instead of this RCN, that is called nitrile, if you are having acid chloride, RC11OCl. In acid chloride, normally Cl having higher electronegativity, so Cl definitely will pull electron, and as a result we will get RC11O plus acyl cation. So this acyl cation means carbon having positive charge. So as we know, this is nucleophile and it will attack on this carbon, and as a result RC11O C we will get. This compound by further treatment with 2-lithium-1,3-dithiene, replacement of this hydrogen is also take place, and both the side we are having this ring, and then after by hydrolysis, means by treatment with HgCl2 water and acetonitrile, we can remove it, this part. Here also we can remove this part, and then after we will get C11O group. Here also C11O group. Now if you are having carbon dioxide, as we know, the carbon dioxide is a non-polar compound, but in presence of this reagent it become polar. The reason is we are having C minus and Li plus. When we are having C minus and Li plus, then what happen? This is polar, so definitely here also we can observe the polarity, and this effect is known as electromeric effect. Due to the electromeric effect, one oxygen will pull electron, so this oxygen become negative and other oxygen become positive. So with positive carbon, other atom, that is carbon, become positive. So on the positive carbon, the negative carbon will attack, and as a result we will get C double bond O OLI. And then after by treatment with water, first of all here OLI will convert it into OH, and finally by treatment with HgCl to water and acetonitrile we will get RC double bond O C double bond O OH. So keto acid also we can prepare with the support of 1,3-diethane. So these are the wide application of 1,3-diethane. Various types of compounds we can prepare with the support of 1,3-diethane. If you have any question or any query, then I will give you 1 minute. You can unmute yourself, ask me. Okay, there is no response from you. So I consider that whatever I have discussed, that you understand properly. Now I am going to discuss about the another reagent. Its name is LDA. LDA means lithium diisopropyl amine. When we are talking about this LDA, first we have to understand the chemistry of nitrogen. Nitrogen having atomic number 7. So its electronic configuration 1s2, 2s2 and 2p3. This is called outer shell. In the outer shell we are having 5 electrons. Now during hybridization, what happened? The mixing of these two orbital, that is called S and p orbital. So when we are having sp3 hybridization, in sp3 hybridization we can see we are having 3 half fill orbitals and 1 completely filled orbital. So these 3 half fill orbitals are available, which indicate that nitrogen can form 3 bonds, and that's why we can call valency of nitrogen is 3. This is the valency of nitrogen. Valency of nitrogen is 3. It means nitrogen can form 3 covalent bond. But when nitrogen form 3 covalent bond, but as per the orbital, one more orbital is available and it having how many electrons? 2 electrons. So nitrogen can form one more bond. But in that bond, the sharing of electron from nitrogen only, and due to this character we can write this form of the bond, and that bond is known as coordinate covalent bond. This bond is known as coordinate covalent bond. So now we can say nitrogen is attached with the 4 hydrogen, but one is via coordinate covalent bond and remainings are by covalent bond. But as per the valency or as per the uh, hybridization, nitrogen having 3 valency, and as per the octet rule, nitrogen having 8 electrons in its surrounding. That's why ammonia is a stable compound. But nitrogen has donated electron to the proton, so what we can call this nitrogen is base or basic in nature. It's a base. This nitrogen having basic character, or we can consider as a base. So same thing now over here. Instead of 2 hydrogen, here we are having isopropyl group. Isopropyl means CH, CH3, CH3. Here one isopropyl group, here another isopropyl group. And instead of third hydrogen, we are having Li. The lone pair of electrons are available with the nitrogen. So as per the characteristic of lone pair of electrons are available on the nitrogen, this nitrogen is known as base. Here Li, which is attached with the nitrogen, so Li having a tendency to to donate electron, and Li is always electropositive, and that's why here it is known as strong base. But the condition is it's a strong base, but it will not give you nucleophilic reaction. That is called nucleophilic substitution reaction. Why? As per the valency, as per the octet rule, this compound is stable. But this compound having additional feature that it can form a bond with H plus, and that's why it is known as base. That's why it is known as deprotonating agent. So here LDA act as a deprotonating agent in a reaction. So once we are having deprotonating agent, means what further reaction will take place, that we will discuss in the next slide. But what is the tendency, what is the nature, or what is the characteristic of LDA, that I have explained over here. If you have any confusion or doubt, then you can ask me. Otherwise, I will move further. How we can prepare LDA? LDA we can prepare it from diisopropyl amine. This one is also known as base. This diisopropyl amine, when we are treating with butyl lithium, okay, when we are treating with butyl lithium, hydrogen will be replaced by Li, and hydrogen Bu will bind with Bu minus, and it will convert it into BuH. It will convert it into BuH, means butane, and Li will bind over here. So we are having now LDA, lithium diisopropyl amine. Already I have discussed, so I am not going to discuss about the things. Now I will start with this reaction first. Whenever we are having carbonyl group, we always talk about that oxygen will pull electron, carbon become deficient, and as a result what we will get, O minus, C plus, and CH3. So if nucleophile is there, then nucleophile will attack on this position and further reaction will take place. So O minus, Nu, Ca3, CH3, and then after further reagents and further reaction, chemical center further reaction will take place. This is the normal reaction if we are having carbonyl group. But here, as we have discussed about the characteristic of LDA, LDA is known as base. LDA is known as nucleophile, but sterically hindered nucleophile, and that's why that's why it will not act as a nucleophile on the carbon, but it will act as a deprotonating agent. How it works as a deprotonating agent, that we can understand over here. When I'm talking about this CH3, okay, I'm not going to write the whole structure, but this CH3 is attached with O, C double bond O, carbonyl group. This oxygen will pull electron. So definitely this become plus. When it become plus, it will try to pull electron from the neighboring carbon. So these bond electrons are slightly towards this electropositive carbon. When it is slightly towards the electropositive carbon, then we can observe the hyperconjugation effect over here on this hydrogen. Due to the hyperconjugation effect, these bond become more labile. When this bond become more labile, then what happen? Hydrogen will be eliminated as a H plus and carbon become negative, and this H plus will bind with LDA, IPR, isopropyl, Li, and H will bind with this. Okay. So removal of proton, that is called deprotonation, will take place with the support of LDA. When deprotonation will take place, at the same time what we will get? C minus, means by treatment with LDA we will get carbon ion. We will get carbon ion. So in the reagent chapter, reactive intermediates, I have explained how we can generate carbon ion from acetone. But here I have explained the same thing with the support of LDA, lithium diisopropyl amine. So we are now we are having carbon ion. Now carbon ion, if we are having, and this carbon is attached with the another carbon, this carbon having which character in the nature of, or which functional group is there? Carbonyl. So what happened? Oxygen now pull electron and this electron will migrate over here. So as a result you will get C double bond C over here and oxygen having negative charge. O minus we will get. So here LDA act as a deprotonating agent, and then after the further reactions are take place with the support of various chemicals. But what is the role of LDA here, that I have explained here. Now here another example. I am having the RCH2 C double bond O R. When we are treating with LDA, then first of all what happened? Proton, instead of this CH2, I can write this form of proton. So proton will be abstracted or trapped by LDA. So LDA will pull electron, abstract proton. So here this carbon become negative. So here it is mentioned carbon having negative charge. So we have generated carbon ion, and then after, due to the electron transfer, what we will get? C double bond C OLI. This we will get. Second thing, during the reaction, what will be eliminated? Here you can see. Finally, elimination of diisopropyl amine. Now this diisopropyl amine is known as what? Is known as starting material for the preparation of LDA. So whatever amount of LDA we are using, the whole LDA will be used by the reaction and it will give you what? Diisopropyl amine. And this diisopropyl amine we can use for the preparation of LDA with the support of butyl lithium. We can again get it. So this is the advantage of this reaction. So whatever amount of LDA we are using, that LDA will convert it into diisopropyl amine, and that diisopropyl amine by treatment with butyl lithium, again it will convert it into LDA. Now this reaction where we can this reagent where we can use for the preparation of important derivatives. Here one more example, we are having two groups. Here you can see one is Ca3, another is CH2. Now if we use sodium ethoxide or sodium methoxide, Ca3O minus Na plus, this is sodium methoxide, and Ca3CH2O minus Na plus, it is known as sodium ethoxide. If we use weak base, then weak base will react with more active hydrogen. Means weak base will attack on this carbon, because this carbon having C double bond O group over here and C double bond O group over here. Mean both the side C double bond O group is there. So this hydrogen is more acidic, and that's why weak base will react with this and we will get monoanion. But when we are using LDA, so with the support of LDA, if we carried out the reaction, then LDA will react with this carbon, means the proton of this carbon as well as proton of this carbon. It means it will react or attack on methyl hydrogen, and it will also attack on methylene hydrogen. On both the hydrogen it will attack or react, and deprotonation will take place from the both the place, and as a result we are having dianion. So if we are going to use LDA, then you will get dianion, and then after we will get this intermediate and the further reaction is take place. Now one more example over here. We are having two hydrogen under neighboring place of carbonyl group. Here one hydrogen and here another hydrogen. But both hydrogens are having different environment. Here you can see methyl group is present, which is known as bulky group, and that's why the steric hindrance is there. And here only hydrogen. This is common for both. Okay. But this another attachment is different. So this is called sterically hindered proton, and this is called non-sterically or non-hindered proton. Now LDA, as we have talked, LDA is base but sterically hindered base. So LDA will not attack on this position. LDA will not attack on this position, but LDA will attack at this position, and as a result we will get carbanion over here. If we are using normal base, then reaction may take place over here. But if we are going to use LDA, then reaction will take place over here, and as a result the further reaction will take place, and we will get different types of products. I will explain you in the upcoming slides. Nowadays, instead of isopropyl group, we can introduce some more groups over here. So isopropyl group is a small group, even though it is known as sterically hindered group, but instead of isopropyl group, we can introduce silicon, that is called trimethyl silyl group, which is more sterically hindered than isopropyl amine. So these type of compounds are available in the market. Its name is lithium hexamethyl methyl diisosilazane or LHMDS. Same way, instead of only isopropyl group, we can use cyclic compound also. So more sterically hindered base we can prepare. Its name is LDA.mp. So these type of reagents or other substituted reagents are available in place of LDA, but they are having characteristic like LDA, lithium diisopropyl amine. Here our purpose is to discuss about the LDA, so we are not going to talk about the other reagents, but we will focus only on LDA. Now, as I said about LDA, we are having two options, here or here, but LDA will attack on this proton only. LDA will attack on this proton only, and as a result it will give this intermediate, and then after further electron will migrate and negative charge will be on this position, and further reaction will take place. How the reaction is take place? Here the examples. If you are having 2-methyl cyclohexanone, then by treatment with LDA, first of all we will get negative charge by replacement or by removal of this hydrogen over here, and then after the electron transfer will take place, so double bond over here, and O minus Li plus will form. But again it will convert it into C double bond O, and this double bond electron will migrate over here, or we can show it react with Ca3i. Now methyl iodide in CH3i, I will pull electron, and that's why CH3 become plus. So it is called methyl ion or cation will form. Now in methyl cation, what happen? This Ca3 will attach with or react with this carbanion, and as a result we can see we have introduced what alkyl group over here. We have introduced alkyl group over here. So with the support of uh, LDA, we can carry out alkylation, we can carry out acylation, we can carry out further, or we can prepare a various kinds of substituted derivative of from alkyl halide or alkene halide. Here, instead of alkyl halide, we can take alkene halide, CH2 double bond CH, CH2 Br. Here removal of Br will take place, and as a result we will get this product or this substitution over here. We are having C6H5CH2Br benzyl bromide. In the benzyl bromide, removal of Br minus and the CH2 will bind over here. So we are having substituted, that is called benzyl derivatives also we can prepare. So various types of derivatives we can prepare with the support of LDA. Now here you are very much familiar with the reaction that is called aldol condensation. I think you are very much familiar with the aldol condensation. In the aldol condensation, normally what happens? Ketone and aldehyde will react with each other, and we will get ketone and alcohol group in a one compound, and that is known as aldol condensation. Means alcohol and aldehyde are we will get this. How it works means, if you are having ketone, this ketone by treatment with base, here base is simple base, that is NaOH, which is known as a strong base. So strong base can react on this, and as a result we will get sorry we are having two active protons. One is methyl and second is methylene. So strong base will react with this CH2, and as a result, first of all we will get Ca3 CH minus C double bond O CH3. Okay, and then after, this electron will migrate on this position, and here as a result we will get CH3 CH double bond CO minus and CH3. After that, by treatment with benzyl acetaldehyde CH3 C double bond OH, when we are treating with acetaldehyde, it will convert it into CH3 CH. Means why it is bind over here? Because this will again convert it into C double bond O, and this will convert into CH minus, and as a result we will get CH3O minus. After that, by treatment with water, we will get CH3CH, CH3OH and C double bond OCH3. Now, if we are using LDA, so LDA, as we have discussed earlier, if sterically hindered proton is available, then LDA will first attack on less sterically or non-sterically hindered proton. So this proton, that is called methyl proton, is not a sterically hindered proton, and that's why LDA will attack on this position, and as a result what we will get? We will get CH3 CH2 C double bond O CH2 minus carbon, and then after electron will migrate on this position and finally on oxygen. So as a result we are having this compound that is called CH3 CH2 C double bond C double bond C H2O minus. In this compound, when we are treating with aldehyde, that is called CH3 C double bond OH, the substitution will take place over here. So we will get CH2 CH O minus CH3, and finally by hydrolysis we will get CH3 CH2 C double bond O CH2 CHOH CH3. Here aim is to explain this reaction is LDA will attack on less sterically hindered proton, and as a result we will get different products as compared to the normal aldol condensation. This is normal aldol condensation, means by using base, that is NaOH or KOH, and this is aldol condensation with the support of LDA. So here you can see the difference between the product and why this happened, that also I have explained. Other derivatives are also we can prepare with the support of LDA. Already I have explained for this kind of compound, here H, and here H. So this is sterically hindered. So reaction will take place on this position. Deprotonation will take place from here. As a result, we will get this intermediate first, and then after, by treatment with serine base compound or serine derivative C6H5 SEBR. Here removal of Br minus will take place. This become plus, and we will get Se over here. So selenyl ketone we will get. This compound by further treatment with H2O2, removal of this group will take place, and we will get double bond over here. How it works, that is explained over here, but right now it is not important as per the discussion regarding the LDA. So I am not going to discuss, but for your reference it is mentioned over here. Some other derivatives already we have discussed. Now if you are having a ester rather than ketone, then what happens? Here we are having C double bond O, OCH2 CH3, and here CH2. So here you can see the difference. This is called alkoxy type CH3 CH2 CH3, and this is CH2. So what happens, whenever this carbon will pull oxygen will pull electron, immediately this oxygen having lone pair of electron, and this oxygen having lone pair of electron, that lone pair of electron will transfer on this position. So there is a less effect on this CH2, but when it pull electron, there is a maximum effect on the carbon which is directly linked with or directly attached with the carbonyl group, and as a result this proton, means proton or hydrogen attached with the carbon, is become more acidic as compared to OCH2, and as a result removal of the proton will take place from here, means deprotonation will take place over here, and that's why we will get carbon ion and we will get this product. So this is the difference between on which CH2 LDA will attack and why these products will form. So if you have any question or query regarding this LDA, I will explain. Here just for your reference, I have taken some examples. The most common thing, the reaction will take place on this position and a further reaction will take place. For your reference only, different types of structures are there, but the basic concept, mechanism and the reaction conditions and the characteristic of LDA is remain same. Now if you have any question or doubt, then you can raise your hand or you can ask me, so I will answer your queries. Check any question, queries. Okay, if you don't have any question or query, then I think I should stop over here, because if I start new reagent, then it will take more time. I'm not going to discuss about that reagent right now. Its name is sodium cyanoborohydride. It is known as the reductive amination reaction. So what is reductive amination reaction we will discuss uh, later on. But right now if you have any question or query, you can raise your question or query. Otherwise we can stop over here. Okay, if you don't have any question or query, then I'm thankful to everyone, those who are present. I'm requesting you that my labs as well as my practicals will be continue as per the schedule, as I have already given the schedule for practical, and your theory classes will be conducted on every Tuesday. If I will get a time, or if you are agree, then definitely I will arrange extra classes for you. But right now, as per the schedule, I will move, and later on, whatever the situation is, I will update you. Thank you one and all. You can leave the meeting now. Hello.